right, so a little bit about myself. I'm working on my pigeon. Everybody's being very patient and helpful, so I'm really trying very hard at this. Halfa, I'm Amanda. Was that, for anybody at my workshop earlier, was that much better than my workshop? All right, thank you. Keep helping me with this. I'd really like to learn more. I'm an engineering manager at Google. I've been working on being an advisor for the open source community Africa team since I met Samson last year in May at PyCon. Co-author of Feature Engineering. I'm also an organizer for Seattle PyLadies, and I hear there are some local PyLadies groups. So if you're interested in that, we'd love to talk to you about that more as well. I'm also a Chrome Dino enthusiast. I love playing the Chrome game, and I'm a mom. Representation is important. And like we said a little bit earlier in the bio, when I come to think about not just why I'm here, but why it kind of motivates me to do my work in general, I'm supremely fascinated by what happens and the difference that happens in the world between the thing that we try to do and the systems we try to design, and that what emerges out of them. And sometimes those things are positive, and they go in ways that we don't expect them to. And sometimes they can be really negative. But I'm really interested in understanding the difference between the intention of why we build things and then what actually ends up happening once we put things out into the world. And so because of this, I recently moved, just in the last 2 months, to the Google open source team. And the work that I'm doing there now is to understand the ecosystems of open source. And when we say ecosystems, we're talking about everything that happens and contributes to and creates open source systems. So like all of you, like Oscar and the Oscar community, you're part of this ecosystem. It's not just the source code. So we want to understand what is happening that promotes and grows and creates positive, healthy, and strong open source systems. So today, we're going to focus a little bit on data science, because that's kind of my background and the things that I learn about. And so we're going to talk about ecosystems of data science. Now, a lot of times when we talk about data science, we talk about the process. And we think about the process in terms of how we actually execute on the work. And a lot of people like to draw this process in this really nice line. And so they'll start over here, where somebody has an idea, and then they do some research, and then they come up with a hypothesis, because that's really easy to do. And then they'll have some kind of idea of the model they're going to train, and they put the data in the model, and it works out perfectly, and you get this awesome result, and you publish the result, and then you get paid. And they think that that's the process you follow. And in reality, there is no straight line. You kind of just bounce around a lot, trying to figure out the next thing that you do in order to actually get to this idea that you have some kind of outcome from the thing that you're working on, and also you start getting some feedback on whether or not that actually works in reality. Because sometimes you put things out into the world, it doesn't behave the way you expected it to. And in order to do all of that process, there are a lot of things that you have to build. So there's a lot of systems that support one person sitting down and working on all of this data science by themselves. So the data scientist Monica Rigotti, she came up with this. People would come and ask her and say, we want AI because AI is powerful. And she said, tell me about your data. And they said, what data? And so she realized that there was this very large gap between the idea of how you actually get to this idea of some kind of higher understanding of what's happening and where you actually need to be working. So she created this hierarchy of needs to explain that if you would like AI and deep learning and these big technical problem solvers, the first thing you have to get right is your logging and your data collection and your instrumentation. So the idea of even just doing tags well on your website. You have to be able to store that somewhere. So it needs to be some kind of storage. So then you have to build a storage system, right? And then after you do that, it's not a straight process between going from the raw data that you're collecting and understanding into actually getting models and metrics. There's a lot of math that happens in the beginning, and things get really messy. So this is the data cleaning part. And then the aggregation and the labeling and learning and optimizing, then you kind of start moving into some higher order maths. But the interesting part about all of these things is that they're honestly not really well done still. And that's great. The great thing about that is it gives us all opportunities to have really good jobs. But in order to get to those good jobs, there's a lot of understanding and tools and things that you have to build and know along the way. This entire pyramid can be one person. And I can tell you it's really hard because I've had to do that. You can also break it up into teams. You can break it up into specialities. You can break it up into people working on different parts at different times. When you do that, it's much stronger. Because when one person is doing all of these things, they don't have the ability to ask the questions that need to be asked because they only have one experience, they only have one life that they can relate to, and they only have one viewpoint. And all of those things cause instability in the system when it comes out in the end. And so when we think about data science and we think about open source, we need to think about more than just the tech stack. We need to think about more than just the process. Because when we're talking about open source, we're not talking about just the source code. We're talking about the framework of everything around the software, but most importantly, the community that is formed around that software and that is creating it. And this is especially important in data and data science and ML and AI, because right now that is highly unbalanced. So when we're thinking about it, it's not just the process, it's not just the stacks, it's not just the community, it's the interdependencies that exist around all of these things. Because when we examine that, we examine each of these individually, we start finding that there's challenges to how we've been approaching data science so far. And the way that we can go about improving that is through open source and open source principles. So today, I'd like to talk to you specifically about 3 challenges around process, tech stacks, and community. And that's around open science and introducing and increasing open science, around inclusive NLP, and also around the importance of equitable representation. So when we talk about equitable representation, because we're going to start there, why is this a problem right now? And so I want to make sure that the top researchers that are working in the world and creating products and selling those products to be used are not necessarily the people who are being impacted by these products. So it was only 2 years ago, in 2018, that Timnit Gebru and Joy Buolamwini released a project called Gender Shades. And so Gender Shades took a data set of world leaders that represented quite fairly across race and gender to be able to create a data set of seeing how well do certain APIs that are being sold by companies perform when they're asked to identify race and gender. And when they did this, they found that there was a very large gap. So when they were trying to identify darker males and darker females, the largest gap that exists was a 20% difference in accuracy. So these companies were selling the accuracy of their products as a baseline accuracy without looking and understanding whether or not that actually performed at the level for all people. Now, the implications of this and the reasons why this is important is because there are very real harms and collective social harms that happen when we use these products incorrectly. But here's the part where I want to challenge open source to help to make sure that there is more equitable representation across all of these, not just products, but projects. And so the first part is correcting the open data sets that exist. So the very largest data set that we have, ImageNet, does not accurately represent all areas, does not represent all cultures, does not represent all people. And so I don't have examples of it here, but if you ask it to show something like a festival or a party, it'll basically show like a small girl getting given a cake, but it's not representing everywhere in the world. So the first thing we need to do is we need to correct the open data set so that they do have more representation. And I remember yesterday there was a fantastic presentation on the crowdsource app to start collecting and adding to more data that is being used by some of the folks who are creating work. The second I would challenge you is actually to build your own open data sets. And so there are ways that you can do this of actually pulling together information, making them open for people, hosting them so that other people can use them, that when we say open, we're not saying that all of the work that you're doing that you don't get credit for, that you don't have control over what is happening with that data. All of that exists around the license that you assign to it. So all of the work that you do, you get to put limitations on how you want people to use that data, on how you want them to be able to access that data, and on whether or not they can make money off of it. So there are open source licenses available where you can create a data set and open it up for educational or student purposes, but that companies can't use it unless they pay you. So I want to just encourage that when we talk about open data, just like with open source, there's a lot of different ways to do it. Building open communities is very important because giving people access to these tools and access to these will give and create more understanding. And then the last part is questioning the mean. So part of the most important work that Timnit and Joy did was actually start to really bring power and give voice to the fact that the things that were being sold as these grand solutions to the world were not the grand solutions that they should be sold to be. And the work they've been doing for the past 2 years has been incredible as well. Open source and the challenge of inclusive NLP. So right now, the cloud text-to-speech, Google's cloud to text-to-speech API, which is a paid product, represents all of these different forms of English alone. So I was actually trying to get a whole list of the languages, and it's over like 120 now. It's quite large in terms of representation. But so Google has been making and actually can understand the different ways that people speak English in all of these countries. So if you want to pay for the text-to-speech product, you get access to that. But if you want to use free products, if you want to use free libraries, right now, actually the most powerful free library for this is spacey.io. It's kind of becoming a standard for natural language processing. It actually only supports these languages, so it might be hard to see. So it only supports, right now it supports 11 languages in total around the world. German, Greek, English, Spanish, French, Italian, Lithuanian, Norwegian, Dutch, Portuguese. Does anybody see a pattern to the kind of languages that are showing up, right? So majority of the world is not able to actually have access or use these for higher level programs. So how can we change that? So for making more inclusive NLP, you can create, and so Spacey actually has a process. There's a whole process where you can add more languages. So you can add, they have a whole wish list of languages that they would like to have supported. I would say that probably maybe not all of those are even representative, the ones that everybody here speaks. But you can contribute dictionaries, tokenizers, all of the things that would actually put the language that you speak into an open source language for the rest of the world. And again, you get credit for this. It's all on GitHub. The next is using processes that are more lightweight. So some of the work that we've done to do things like federated learning allow models to be trained and run on your phone so that you're not sending big packets of information back and forth from Google. And so some of the additional work that you can do, TensorFlow, TensorFlow Lite, TensorFlow.js has a lot of work around this. There's some great open source projects you can contribute to that. And the way that makes that more inclusive is because as we're doing this kind of translation work, it makes that work available offline, and it makes that work available for lower data streams. So you actually make it so that when people don't have connection, or for when people want to be able to save their battery power, that they're able to use these similar and same kind of technologies, including developers wanting to put those features into their applications will have access to that because the libraries are easier and better for them to use. Cleaner algorithms. So much of the work that's being done right now, all the direction that we're currently moving in is extremely energy intensive, which is not good for climate. But that's the direction the majority of researchers are working in right now. I challenge that there's better ways. There has to be better ways. But because the majority infrastructure that exists right now is focusing on things that have all of those different layers of access, they're not thinking of new approaches. And so I would hope that by trying to approach and think about if you are using less intensive resources, if you are using systems that don't connect to very large data centers, what kind of algorithms can you come up with? What kind of architectures and approaches can you come up with that we should all be using and opening those up to the world? And then also an increase in open education. So I would love to see the communities and the groups that are doing data science and ML and focusing on all of these issues to start increasing in their localities so that we're not taking courses from Coursera from continents away. But you have somebody that you can speak with and you can learn from and you can talk to about whether or not the approach applies to you. And if it doesn't, how can you create educational materials to teach more people who have those same challenges and to teach people a continent away what they should be doing? And so the last is I'd like to talk about the importance of open science. And so open science and the concept of it is that the way that traditional research is done, and it's done in much of the world, is that researchers focus on performing their experiments and performing their information. They take all of that experience and that information, they publish it, and when they publish it, usually you have to pay to get access to that article. But that's how people have done it in order to maintain and get tenure and get paid, and it's a very broken system. This especially becomes extremely detrimental to fields like epidemiology. So in 2015, with the last Ebola outbreak, a group of researchers decided to reject that process. And they got together, and I think it was within, so 3 research teams within a very short period of time were actually able to sequence the virus at the time and very rapidly work to create a vaccine. So by breaking the constructs that already existed of the way of trying to focus on creating research papers and getting tenure, they actually worked together to make sure that they were benefiting the people who were at risk. And so with this idea in mind, that science should not belong to anybody or be behind a paywall, there are ways that you can use open source to support open science. And I do know that there is a group here, Open MRS, who has been working on open source healthcare records, which I think is fantastic, because that's one direct way in the right direction. So the first thing is, again, we talked about open data sets, opening up critical data. So working with scientists and being able to create platforms and being able to create tools and frameworks to encourage them to open up that critical data so that they can share it, they need software engineers for that. Because I can tell you from experiences, most scientists are not software engineers. They're not building the systems they need to be able to support and share this data. Using open tools. When scientists or people or you are creating any kind of scientific analysis, if you're using proprietary tools, it's very hard for other people to replicate their work unless they have access to those proprietary tools. So you can contribute if you want to support this, but you're not a scientist. The Python Software Foundation is here. They would love to talk to you about Python, which is one of the highest tools that's being used for research and data scientists. Other tools like R, there's other programs that get used to be able to create these. These are core fundamental languages that you can contribute to. Open all of your analysis methodology. So also creating work that allows scientists to be able to share the work that they're doing and the frameworks that allow them to be able to share their analysis and their methodology. So there are software platforms that allow you to do things like share Jupyter notebooks. So this is like a framework that lets kind of like an IDE, but it ends up looking like a book afterwards. The Jupyter project is an excellent open source project that allows people to host their scientific results and allows you to challenge them afterwards. So that's another way that you can get involved. And then I would also encourage to optimize for transparency. So as part of this whole process, that whatever you're working on and whatever you're working it around, make sure that you're designing the work that you're doing so that others can use it and see it and know the process that you're using. And so for bringing this all together, we just really want to point out and understand that data science and open source, they are interdependent systems on each other. The reason that data science is able to achieve what it is today is because that it has been built upon Python. It has been built upon R. It has been built upon scikit-learn. It's been built upon pandas. These are all libraries, open source libraries that people created and released into the world, and other people were able to use to gain access and analysis and understanding. If we were still stuck in that proprietary software stage, we would not be where we are now with being able to have this much understanding of what is happening with all the data that currently exists. Thank you.